calculate the percent composition of an element in a compound, we take the number of moles of the element in 1 mole of the compound and multiply it by the molar mass of the element, divide that by the molar mass of the compound, and multiply by 100%. For example, take C2H6O. There are 2 carbons, 6 hydrogens, and 1 oxygen in this compound. The total molar mass of the compound is 46.07. To calculate the percent carbon, we take the 2 moles of carbon multiplied by the molar mass 12.01, divide by the molar mass of the compound, times 100. It equals 52.14%. For hydrogen, there are 6 moles times 1.008 divided by 46.07 times 100% equals 13.13%. Percent oxygen, there's only 1 mole times 16 divided by 46.07 times 100% equals 34.73%. Remember that the percentages have to equal 100. Empirical formulas can be calculated from the percent composition. In this example, determine the empirical formula of a compound that has the following percent composition by mass. For potassium, 24.75, manganese, 34.77, oxygen, 40.51%. First, we calculate the number of moles of each element. The number of moles of potassium is 24.75 divided by 39.10, or 0.6330 moles. The moles of manganese is 34.77 divided by 54.94, or 0.6329 moles. The number of moles of oxygen is 40.51 divided by 16.00, which equals 2.532 moles. We have the number of moles of each of the elements, but we don't have the simple whole numbers. To get the simple whole numbers, we take the smallest and divide it into each of the others. For potassium, it's 0.6330 divided by 0.6329, or roughly 1. Manganese, exactly 1. For oxygen, 2532 divided by 0.6329 is approximately 4. Therefore, the empirical formula has 1 potassium, 1 manganese, and 4 oxygens, KMnO4. A process in which one or more substances is changed into one or more new substances is called a chemical reaction. Chemical equation uses symbols to show what happens during the reaction. Reactants are converted into products. 2 molecules of hydrogen react with 1 molecule of oxygen to give us 2 molecules of water. Here we see 2 magnesium reacting with 1 oxygen to yield 2 magnesium oxide. 2 atoms of magnesium plus 1 molecule of oxygen makes 2 formula units of manganese oxide. We say formula units because it's an ionic compound. 2 moles of magnesium yields 1 mole of oxygen, making 2 moles of magnesium oxide. Balancing chemical equations. We'll practice a lot of these in class. Here are these steps. Write the correct formulas for the reactants on the left and the products on the right. Here's an example. Ethane reacts with oxygen to form carbon dioxide and water. The symbols C2H6 plus O2 yields CO2 plus H2O. Change the numbers in front of the formulas, the coefficients, to make the number of atoms of each element the same on both sides. Do not change the subscripts. Start by balancing those elements that appear in only one reactant or one product. So we see in C2H6 there are 2 carbons on the left. There's only one on the right. So we start with the carbon, not the hydrogen. We multiply the CO2 by 2 to give 2 carbons. We see the 6 hydrogens on the left, so we need to multiply the hydrogens on the right by a 3. So far we have C2H6 plus O2 yields 2 CO2 plus 3 H2O. Still don't have the oxygens balanced. So we'll balance those elements that appear in 2 or more reactants or products. We have 2 oxygens on the left, 4 in the CO2, 3 in the water, total of 7. We need to multiply the O2 by 7/2. However, we don't usually express things with fractions, so we need to clear the fraction. We have 2 C2H6 plus 7 O2 yields 4 CO2 plus 6 H2O. We have a balanced chemical equation. To check to make sure that you have the same number of each type of atom on both sides of the equation, everything balances.